Well, this is a summary of my presentation, or the table of contents of my presentation. So I hope that my presentation is entertaining. So if you are not on the technical side, do not get scared about my presentation, because we will be looking at security elements that are very important, such as NAT, pivoting, basic IPv6, and then we will finish off with demos, and we will be using Rocket and the Skydive tool to see the network configurations that we have in these elements. Okay, so today I'd like to introduce myself to say that I'm passionate about network security. I've also been doing research on IPv6 for many years now. I've also founder of a startup, Mr. Luca. I've always had a very close relationship with INCIBE. They have supported us a lot when we created our startup. This was 2 years ago when we received the third prize for startups, and we have always had the significant support from INCIBE. This year we have received the support, we've been receiving the support in the program for Business Accelerator. So in the photograph you see my partner. My partner and myself took this photograph in Athens. So Athens has its headquarters at the ENISA, the European Agency for Network Security, has its headquarters in Athens. So we produced the paper, and part of the content of my presentation today comes out from that paper that we produced about security implications of IPv6. We will not be focusing purely on IPv6, still I will briefly refer to it. Well, from our startup, and that is of top concern to us and that we are trying to communicate all the time, is the importance of considering and taking into account those elements that are exposed to the internet. And this image is intended to represent what we internally imagine when we expose a service to the internet, when we open a port 80 port or SSH port or any other port which is secure, but that is also open to the internet. The moment we come out to the internet, it is like if we were at war, at trenches, waiting for anything or any attack from the enemy. DMZ. So when two Koreas reach an agreement, and in the demilitarized zone, still that was a frontier that as you penetrate it, you could go to a rich area, and that is also an area that was strongly protected. So I could talk about Marriott and any other security incidents. This took place 4 days ago only. Says that a new data breach exposes 57 million records from citizens, companies, etc. More specifically, it says that this is an Elasticsearch service that was poorly configured during auditing. It was found out that it hadn't had any authentication in place, and anyone could access it. And then if you go to Showdown, it tells you how you can gain access to that port. Well, you could listen through that port. You could do very many things with it. So regarding simple concepts such as this one, if you configure Elasticsearch, please include authentication. If you are going to offer direct access, do not expose it to the internet. It is just a database, and only a web app or an administrator should have access to it. If you are updated on this type of things and on this type of research, very often we find this type of data breaches. So in terms of NAT, network address translation, everyone is familiar with it. Many say that NAT may be a solution to a problem. That is to say, well, everyone has heard about how internet started. It was a network created between several universities, and it was never expected to grow as much as it has grown. It was never expected to be a breakthrough for our society, but still continues to be based on IP protocol. And what is the problem? As internet grew, as internet evolved, there were not enough IPs for all the devices that wanted to connect to the internet, and therefore NAT was created. That is to say, a network of internal addresses that will be connected to the internet through internal forwarding. So here we have 3 internal networks. So here, represented with these circles, all these are internet networks, private networks at your companies, your organizations, and they are logging to the internet through few or several IP addresses can be routed to the internet. The rest of the routing and internet connectivity is done through that cloud that we can see here, where internet service providers connect with each other through the routers and offer connectivity end to end. But what happens with IPv6? IPv6 is not often used, and actually it is recommended not to use it, because IPv6 internet was known to be a global network where millions of devices were already connected, and many more millions will be connected in the future. And one of the objectives of IPv6 is to restore end-to-end network connectivity. That is to say, allowing all the internet devices to connect with each other. The idea is wonderful, and IPv6 is here with us and allows us to do that. It simplifies connection of all these devices to the internet. Now, the concept of pivoting. So this is a definition from BBCE about MBC about pivoting. After stopping with the ball, pivoting allows you to change direction and look for a pass or a shot. How can we translate that into hacking world or exploiting and post-exploiting time? Well, often it takes place like this. We have a private network here on the right. We have 2 devices, and then on the left we have the internet with a public address. So internal traffic cannot be routed to the internet. That IP will never reach the internet. You may try it, but at a given point in time it will be cut off. For that, IP addresses are being used, and then it will use one of the ranges that are not reserved for internal directions. So what happens in exploitation and post-exploitation phase when we want to pivot? Imagine that the service that the victim machine is exposed to. Imagine that we manage to exploit it. Then I take control over it, but the concept of pivoting is very powerful because it allows us to reach victim 2. Therefore, it allows us to change the address and therefore to reach the internal network. And for that, I may launch attacks right away from victim 1, or often done is that the routes of victim 1 are changed so that I can pivot and reach victim 2 right away. And this is one of the things that you always have to do, especially when it comes to exploiting. And this is very good fun, especially when you are carrying out an audit. Okay, and I leave it there. Now, IPv6, well, I could talk ages about it, and it is not relevant for today's conference. Still, I would like to show an IPv6 address. Any address starting with 2 could be routed to the internet. So those dots stand for zeros, and often we always have these sections with zeros unless these directions have been randomly produced. So now I'd like you to focus on these 2 parts, the blue one and the green part. So on the left we have blue, on the right we have green. What does that mean? The first bit stands for the network address, and the second bit stands for the host address. So what does that mean? That if I'm given control of an X network, the rest of the 64 bits could be redirected as I would like to in my network. 64 bits, 2 to the power of 64. How much is that? That is a lot. So there is also a debate in IPv6 about the following. Some administrators say, why so much redirecting given to ordinary users? Because the 64 bits is the ordinary access that you give to any network. Any network, we should have a minimum of a prefix of 64 bits. IANA and RIRS recommend using 64 subnets everywhere in your network, and including point-to-point links. This is when hosts connect to each other through a network in between them two. The network has 2 addresses. So in IPv4, we have the address and the broadcast address, and these are the 2 addresses in between the 2 devices. How do you direct that for large customers? Often large customers get a -48 prefix, medium customers get a 46 prefix. Well, we are not going to go into all the detail about subnets. So by the time IPv6 will reach your homes, if you don't yet have it, you should have been given a -64 prefix, which is very good to play around with it. I can assure that to you. And I told you before that at very low cost, you aid in having a good IPv6 with a -64 prefix, all for you. And short ago, we posted to GitHub this paper that we have produced, and you may download it, and the project is based on the demo that I will be sharing with you now. Well, it is based on Docker, so you will have to install the relevant dependencies. And it is based on Skydive, which is a project I would like a lot, allowing us to see the topography of a web browser in all the machines that we will be starting. Okay, I will start the virtual machine. I have an ISO with VirtualBox here, and so I will start it. Well, it has the projects and all the components installed. You may install it locally or in a virtual machine. The virtual machine that I'm using now well, I could install it here, but it is not very difficult to install. It is based on Kali. I don't know whether you can read it or not. I am starting with a script, with a setup. You see all the environments being started. We have the Elasticsearch, Skydiver, everything is automatically configured. Then we are starting the different machines. We have referred to them as victims. And now I will show you this Docker Compose. For those of you who are not familiarized with it, this is a file that when you set up Docker, you ask the system you tell the system the machines that you wanted to start for you. So these are all the victim machines. These are all the Docker images. And this is configured in the project. You don't have to do it yourselves. And then I tell him that the host, that victim, will have two IP addresses, an IPv4, which is internal, and an IPv6 address. And everything is ready. Okay, and this should open automatically. So these are specific attacks of IPv6 that we presented in our project. But because they are not the object of this presentation, and this window is in the way, we will close it. So this is my Kali machine, and I will expand it now. So here we see all the nodes. In the beginning, I found it a bit messy. I thought that this design was not user-friendly, so to speak. But I'll explain it to you. This is my Kali machine, represents the local host of the virtual machine, and each of these pink circles stand for Docker machines with their own network configuration that we have defined in the Docker Compose. I will continue to extend it because these things that we are seeing here in yellow, well, this that I'm pointing out is an intermediary device. It's a bridge, but we consider it as a device. You can see it has its own IPv4 address as well as its own IPv6 address. Each of its machine has an IP address. Sorry, a network address. Okay, victim 5, starting by 5.3, and then in this pink square, we have a symbol for interface, then we click on it, and we see the network configuration. 10.16.253 to 802.16.33. This dash 64 means that the first 64 bits are for the network address and the last 64 bits are for the host address. If we were to click on another one, for instance this one here, you will see that it says 82. So this is the fixed part of it. The first part, the first 64 bits are fixed because they belong to the same network, and what changes is what comes at the end of the address. The good thing about it is that I have started my environment. And now I can go to machine, for instance, to this machine here. Network connectivity, I can do a map. (1016.253). So some services are open. So therefore that means it could be in any host. So if you cannot see it, just read it, just let me know. I could also do SSH. And this is IPv6 address. I'm starting to have connectivity. And then Skydive is very nice. When there is connectivity at any point, then you get these red lights. Now I'm going to configure in my interface an IPv6 address from the address that have been started in Docker, so that I can get access to IPv6 address of those hosts. Okay, I will zoom in. Config, the only IPv6 address is this one here, but we cannot go into this one. ifconfig et0. I ask it to configure IPv6 address for me. Okay, we go back to network configuration. So we see that we have an IPv6 address configured with a prefix that we have, and this gives us access to our Docker machines. So this is IPv6 address, and let us see if I can do ping. That machine, well, no problem, I can do that. And now let's simulate. Let's change the configuration of this environment. Like if it were to configure those DMC, that public part and that private part. In my Kali, I'm going to configure a public IPv4 address, and I'm going to change this public address with another public address. Therefore, I go to interface, I do ifconfig, then interface, and then it will be 66778844. And you'll see how network configuration changes. Can you see it? Has changed. And that network element, which is this one here, and that will communicate with Kali right away. In my IPv4 has given a public directioning. For instance, simulating that it is an IP of our DMC USF that is exposed to a given service. And then we have Kali. We have an icon for our interface 0, this one here. So we see the network configuration that I'm entering. I will be changing that, and I will say instead of this internal one, I will be entering a public address. 607754.89, as you wish. I will be changing that. And what will happen now? You will have access to 66.778844. All right. And what will happen if I try to do ping to those that have been internally redirected here? Can you remember some of them? For instance, okay, let us go for this one. Okay, this one here. 1016 to 53. I can see that I cannot access them because it tells me that destination network cannot be accessed. So the configuration underlying it, behind it, simulates the internal configuration of organization, which is in the NAT, and outside we have different nodes communicating to the internet. But I insist in IPv6 you don't get NAT. So therefore, this network configuration that we see here can continue to be routed to the internet. And what does it often happen in the world of IPv4? If from my Kali I want to attack any of these internal machines, well, I move on to pivoting concept. I attack this public IP, then I check the services in it.
Veo que tengo ahí unos cuantos puertos, unos filtrados.
I have a series of ports. Some of them are filtered. I have one open. I could attack. I could launch an exploit. And once I'm inside, I can access any of these machines. But as you can imagine, with IPv6, if they have a directed and this is behind, I may access that, perhaps. So let's see. There's one here. Let's see if I can arrive with my current configuration. So I arrive, I connect, and I can launch an NAP to discover the ports that are open. So I can connect to that host through SSH. And we see that we have a private rerouting, and we cannot arrive at the place where we are. And we have access because we have the IPv6 address, which is exposed, and we're connected to it. And you can see how we're generating this traffic through this call machine, which is here. And I'm connected, and I didn't have to exploit. I pivoted. Any questions so far? Are you lost? I have a question at the back. Am I allowed to take questions before the end? I guess I am. Now let's see other real cases, then we come back to this environment whenever you want. We have this environment here. Cal has a public address. This one also a public address, but the others are internal. But IPv6 addresses, when they come to a network, when we want to reroute, we do this thing I've just done. With regards to firewall and other issues, well, we can do it. I think I saw that you were scanned with IPv4, you were given the same service, and with you scanned with IPv6, the same host, you had different services. No, okay, I'll exit this. I cannot. Well, I changed the configuration and we'll see it. This is this machine here, 53. We can configure this with 10. This is an interesting question, because I'll explain now the notion I'll use 1016 here. I use this so that we don't have collisions. Let's see if I arrive there. What was it? 53, right? NMAP. I think it's regular, right? $22,443. If I do nmap for NMAP to 53, this is the same one. In the network configuration, so that we're not confused, the end address is the same for IPv4 and IPv6. You see, it's the same one. It's interesting that you say that, because the dual stack concept is based on that. The host at the end, the services at the end are the same ones, but very often the exposed ports can change. Why? Because the filtering you do in IPv4 does not take place in IPv6, and that's the mess. Because how many of you know about IP tables? I'm sure most of you, or at least you've heard about them. But you know how to configure IP tables in IPv6? Well, less, because it's IPv6 tables. So unfortunately, IPv6 has a series of advantages and is rich in many environments and infrastructures, such as cloud environments. But people do not have the skills, or it's hard for them to see due to our speed. They don't bear in mind that when we're using IPv6, we need to bear in mind that it's a different interface with a different routing that offers an access to the same machine. And we'll see examples in which the open ports in 4 and 6 do not coincide in real environments. Real world. What about IPv6? Well, this doesn't exist in Spain, we don't care. It's a future protocol, but it hasn't here yet. Regardless of the statistics you see on the internet, Google says that 25% of its traffic is in IPv6, so 1 out of 4 connections is IPv6, and their carriers such as T-Mobile, which has 90% of the traffic in IPv6, most likely. You know, companies, organizations that have things in Amazon. Do you know anyone that has something in Amazon? Well, this is what Amazon says. Amazon Virtual Private Cloud, these famous VPCs. We can have availability zones, which are the zones in which Amazon generates a sort of data center availability for creating virtual machines. This subnet 10.0 something internal, but see the IPv6. It says /64. It starts with 2, so it's routable to the internet, and it says that the machines raised here. You have to be careful with this, because the main cloud providers, Azure, Amazon, Google Cloud Platform, have IPv6, and many machines, many VPCs have been raised without having security considerations. Let's see something else that people say when they face IPv6. They say, if I configure my IPv6 addresses randomly, they're difficult to guess, perhaps the attackers won't know where my machines are located. The notion of pivoting is not I exploit a machine to get to the others. I can get to all of them. I just need to know where they're located. How can I know which machines belong to a specific organization? Well, I'll ask this question later. Let's see how some organizations are working with IPv6 rerouting. They do things such as this one. A certain domain, @works.co, changes from 173.245.60.183 to its value in hexadecimal, and it's included into the IPv6 address they generate. This is the network address, and this is the host address. how do you think we can know whether another host, another IPv6 address belongs to that same organization? Let's imagine that I'm analyzing that organization. I'm doing pen testing, and I already have this IPv6 address. How can I know whether this one belongs to the same organization? With the network address. Of course. Let's see another example. Other people have assigned this prefix 2001, 41D, whatever. They take their regular IPv4 address that I've traditionally have. They've been administering for a long time, and they include it like that. If you translate into bits, it's not different because this is decimal and this other thing is hexadecimal. But to let it more legible, more manageable, many organizations are doing this. So this could give us a clue. If we know the public IPv4 address of organization, we can check whether it is in IPv6. There's something interesting here. These are real domains. I'm not showing sensitive information. Domains that have nothing in common, apparently, at first sight. This is like intelligence test, find the differences. Well, if you see IPv4 addresses in IPv6, in IPv4, we see the same 3 blocks are the same ones, but in IPv4, if you give me 2 addresses, I cannot know if they belong to the same organization if I'm not using additional techniques. Just with the IP address, I cannot know. However, with IPv6, what happens? If you try to solve this, you'll see that the prefix is exactly the same. What tells you? What does it tell you? From an infrastructure management and network point of view, all these host domains are related. And what happens? These are virtual devices that are generated in this environment, node, maintained in the same infrastructure. The routing goes to the same place. And could we guess other hosts that are there? Well, it shouldn't be too difficult. The internal domains generated for each IP are quite predictable. And now, based on the question you've asked, this solution we haven't missed a look at experimental level, the startup we created. What we do is combining IPv4 and IPv6. This is not available in the internet. We expect it to be available over the next weeks. And I'll show this to you now. It's important to show the concept. There's a host, an element, final Docker, in this case with this weird name, that may have 2 interfaces, and each one of them has different ports. You get there through different parts. You filter here, perhaps you're not filtering the other side, and vice versa. Perhaps you filter in IP4, but not in IP6. And very often, what we see is that these security policies are not being considered, are not being properly considered. The goal of Mr. Looker project is combining IPv4 domain IPv6 to show that the device behind it is the same one, and therefore it is important to apply the appropriate filter, the appropriate network configuration. If this host, this domain, if you apply nmap or you solve IPv4 address and then IPv6 address, and you apply an MAP to each stack, you'll see there are differences. We want to point this out, and that's why we mark in red the ports we see in one side and we don't see in the other ones. It doesn't mean that it's safer in IP4 and not in IPv6. It doesn't make sense for it to be different as of today. If they have the same network, the same access through the internet, why the configuration is different in stack IPv6 and IPv4?
Otros ejemplos.
Other examples that we want to show. I have some queries here. Let's try with this one. With another one who has open ports. And now you would say, well, it's a compliment. It isn't better or worse, it just complemented the vision of the view. Let's take an IPv6 address, such as this one. And let's carry out a search. I don't know whether we're going to get something, but could anyone tell me what I'm trying to do with this query? As a matter of fact, I could remove the host address. It's not necessary. I'm trying to obtain all the hosts that may be somehow related to this other one. Why? Because I'm using the address and the prefix to search. I don't know what I'm going to obtain besides the one I already have. Well, we have 7 different machines, 7 different IP addresses. If we have this case, we have this domain. There's nothing in IPv4. In IPv6 we have this address, and we have an SSH port which is open with a good vulnerability. This has a potential, because if you don't have the right security policy, you'll have a problem, because if someone knows one of your IPv6 addresses and they want to pivot because they're not interested in that machine, they can guess whether that organization has other IPv6 addresses which are exposed to the internet. They just need to discover IPv6 addresses which also belong to the same IPv6 prefix. And look how simple it is sometimes to find security breaches when you find open ports. Well, this was my presentation. We have 5 minutes more. We can have a Q&A, or we continue with the practical side of this. Any other question, comment?
Bueno, mi duda es sobre...
I have a doubt related to the example in pivoting we've seen. We've seen that when we have a network configured as private, we access the first machine, and from that we can pivot to the second one. In IPv6, if I access a machine with an address, can I then access a network that is configured as local link? Can I jump from one IP to the other? Yes. Let's imagine we have our environment. I'll use the SSH access. I'm inside the machine. We have internal routing, IPv6 public address, but also the link local routing. This routing, starting with FE, is the one you can see in IPv6, both in Linux and Windows systems, with the proper actions. This routing is not the equivalent to IPv4 because it behaves differently. This network address is automatically generated, and any interface has an local address. In IPv4, we have to configure it ourselves, but as soon as we have an interface, we need an IPv6 address and link local. It's usually generated based on the MAC address of the interface. Why do we need this interface? In order to have immediate connectivity with nodes in the same domain, in the same LAN, connect to the same switch. So LIC MVP6 protocols are used. And I'm going to try something. I'm not sure it works.
Bueno, es que no tengo ni el NetTools instalado.
I don't even have NetTools installed here. If you access, you'll see that very basic Docker machines don't have NetTools installed. That's what you have, the ping and other things. So you type in the proper commands and you'll have the network address, network tools. This is cool in order to discover elements in the same IPv6 elements in link local, because it's a multicast address in IPv6, and default, any machine compatible or active for IPv6 have to listen to that IPv6 address. If I pin that address, all the active machines have to answer, unless it's filtered through firewall at host level. Linux today, I think most of them answer, but not Windows. But from this machine, if we're inside, we're compromised, we could launch a query to see which machines are available at the local level, but we may be more limited compared to the other approach when we go from the outside. We'll be limited to the switch to which we're connected. And because very often there are services which cannot be accessed from the link local side, they're only active on the public side. But yes, we would have the two ways to pivot. Once we've pivoted, if there's a public IPv6, we go from the outside. If they have an IPv4, we go from the inside. And it would be a nice idea. 0.1, and you'll see that some machines will answer. Thank you.
IPv6 se configura manualmente o automáticamente?
Is IPv level rerouting is complex. There are many papers written with recommendations on how to manage the rerouting, because you have to change your mindset. So far, I think it was /16. That's the network subnetting. That's what you learn when you train in networks. Based on how the blocks are structured. And I forgot the question. When you install a router, you connect to a device, everything goes automatically through DHCP. What about IPv6? Can it be configured without me knowing? You've explained a server when there's an HCP server, a router at home, but there's a server which is in the network listening to provide the IPv4 address to the devices being connected. You active your device, you answered, and you get the IPv4. But in IPv6, you don't even need the HTTP server. These addresses and link local are already configured. If you configure an environment in Raspberry. You connect machines, but you don't have any router. You have to access and manually configure the IP. But in IPv6, at LAN level, there's going to be visibility with at least one IPv6 network, which is link local. If it's configured automatically, even more automatically than IPv4, if we're speaking about public routing, these are services which proactively configure this, additionally to link local. And as you can see, there's an important change, and that IPv4 interfaces can only have one IPv4 address that you can change it. In IPv6, there are several addresses, hundreds of IPs, which is another attack. You falsify, saying that a router. In some interface, there are several IPv6 interfaces, and you can create a denial of service. Yeah, you've answered, but that was quite a job. Well, you need to see the other side. If you take security into account, we have more connectivity potential. We're more agile when it comes to configured devices, and many of the organizations that standardize the internet, they want end-to-end connectivity with no intermediate elements like CGMAP that carriers implement. This type of technological solutions, they don't want them to happen. They want to have a flat, so to speak, flat network in terms of connectivity, end-to-end. And it would be more efficient, it would be simpler, and some services wouldn't be so complicated when trying to connect machines behind a LAN network. They have to show their communication protocols. What we want with IPv6 is end-to-end connectivity. From a security point of view, of course, that's what we want to explain. We have to bear this in mind. But IPv6 comes with many advantages from a network point of view. If there are no more questions, either you're deaf, you're sleeping, or you didn't understand anything. Thank you very much.